All right, so welcome once again to the 10th session of this program. As I've been repeating, we are constantly building up knowledge and making a lot of progress. So if you've been with us since the start till now, you should have noticed some changes in your skill or your abilities, right? If you're then in the category of those that had no idea of what Python is or how to program, I'm very confident that you can comfortably handle or work with Python at this point, given all that we've been doing so far. So yeah, that is yeah, kudos to you for sticking around till now. Right. So but we are not done yet. We still have a lot to do. We have now entered the second phase of this program, which is machine learning. This first phase, okay, sorry, the third phase of the program. So basically, the program is divided into three parts. Unofficially, right? We have the initial part or the fundamental part, which has to do with introducing you to Python and the concepts that you need to know in Python. That was where we looked at the data structures, data types in Python. We looked at variables, if statement, for loops, function, and all of that, right? Then we moved on to the second part of the program. We started introducing us to libraries. So we started by introducing us to NumPy library rather, and yesterday I introduced us to Pandas library. So next week I'm going to introduce us to another library, which is Matplotlib, which will be used for data visualization. All right. So that's the second part. So the third part of the program would have to do with machine learning. All right. So that is one one thing that distinguishes data scientists from data analysts, as you've already seen in our introductory class. So the machine learning is going to be like a jump, right? It's going to be like a jump from what we've been learning so far. But we're going to be using a library to implement everything, which makes it very simple to use. But you need to understand a lot of things, a lot of concepts, and how all those algorithms and all of that are working to be able to use these tools. So this is just the structure of the program. So after you're done with machine learning, then um, I'm going to give out our project, and the project is going to come before the end of the program, so you have enough time to work on your project. So more details on that would be um, made known to you. So just know that we are making a progress, and within just we have less than 2 months to go. So yeah, that's just it for that. So today we are going to. I said that I wasn't able to go through the assignments during the week, and I honestly haven't been able to do that still. Right? So I've not been able to do a lot of things, but this class is a necessity. So that is why we are having this class. I don't want us to lag. I don't want us to be left behind. All right, in the curriculum. So making sure that we have this class. That doesn't mean um, every other thing is expected as it's used to. It's used to, right? So hopefully by tomorrow, Tuesday, I would have gathered enough momentum to go through the assignment and return your grade. But still, we're going to go through the correction. All right. I wanted to make sure of that we go through the correct assignment correction. so you know exactly where you missed it. All right, so I'm going to share my screen now. Hope everyone can hear me clearly. Everyone can hear me clearly. All right, all right. So I'm going to share my screen now to quickly go through the correction for the assignment. So let's see if we can do that within some minutes. All right, can everyone see my screen as well? Can everyone see my screen? All right. Okay, so as I usually do, I I just pick a random assignment that did well and use that for correction. So in this case, we have confidence Chinelo. So I don't know. I think it's the first time I'm seeing that name here. I don't think I've seen the person comment or respond to any of my questions of this group chat. Right. So, but this is the person whose assignment we're going to be using for correction today. So, confidence, if you are here, please do well to interact more because I don't think I've seen you interact during the classes we've been having. Okay, so just quickly go over the assignment. The questions, we have 10 questions in total, right? So, on all these questions border around NumPy that we did last week. If you're in the class, this should be an issue or a problem for you. Answering them shouldn't be an issue. All right. So first we have this question one, which says that you should write a NumPy program that creates an array of 20 random integers between 10 and what 15. So remember what I told you about breaking down questions? I told us that when you get a question, especially a programming question or data science question, we break them into different parts, all right? Because to answer the question, you need to answer some part, you need to answer part of the question and then bring them together. So that is going to be the best approach in answering a question. You can apply it to any field as well. So now, the first question, write a NumPy program. All right, so this can be anything, it can be in any way you want to do it. All right, you can make it a function, you can just make it a normal code that is not wrapped in a function. So the program is what a program that creates an array of 20 random integers. Now, what this program is to do is to create 20 random integers. Now you now start seeing that okay, you need okay, there's specified random here. If I didn't specify random here, you know that okay, there's going to be a different approach to this question. But I indicated here that you should create an array of 20 random integers between 10 and what 50. So after you've created this array, right, then next thing to do is then to calculate the sum, the mean, the standard deviation, and variance of the elements in the array and print them each. So this is actually a straightforward question, right? So as you can see here, um, this person imported NumPy as you should, and then you're using the random module. Random module, that's what it's called. You would use the randint function, which generates random integers. All right. So these are the parameters or the arguments that you specify. So this is the starting point and this is the ending point. And this is the number of elements you want. So you can see, right, these are the elements here. So they are actually random. Like you don't need, um, unlike the linspace or the range that creates a value, that generates value for you, but caps the the starting point at a specific value and caps the ending point at a specific value. It's not the same thing with random functions. Random functions they just generate randomly, but if you check all the individual values here, you realize that they are not below 10 and they are not above 50. So you can confirm it by doing that multiple times and seeing the results that you have. All right, so that is what we have here. So to compute the sum, we'll as well just use this np.sum array function. So I want to ask a question just to refresh our memory. Okay, I just want to quickly ask ask a question, although this is supposed to be in a pool format. Do we like this live question or live interaction that happens during our classes? Or let me just create a poll here. Or let's quickly create a poll. Okay, just give me a minute. I'm creating a poll so you can just select. All right, so you can as well just vote on the poll here. So now I want to ask a question. As I said, this np.sum function, what category of NumPy function does it fall under? We need to make it easy for you. Is it under element-wise operation? That is element-wise function or aggregate functions? Okay. Okay. So I think we're all correct. Just one person missed it, but yeah, we're all correct. It's basically an aggregate function because it aggregates all the values in your array and give you an an output, either one output if you don't specify any axis, or multiple outputs if you specify an axis. All right. So that's what I expected you to do here. You use these different functions on the array np.sum, np.min, np.standard deviation, right, and np.var. So you get different answers here. So the sum of everything is 620. The mean is this, the standard deviation. So whenever you are having output like this, all right, whenever you are having an output like this, try as much as you can to always use the round function. There's what we call the round function. This is it here. The round function. So it basically approximates the value into a specified number of, let's say, decimal places, right? So you can see it has approximated. So it's much easier to just look at and understand the output, all right? So yeah, so that is it for number one. So question two, it says you should create a 2D NumPy array with random values between 5 and 15 with the shape of 4 by 4. Now this is the first part. Create a 2D NumPy array with random values between 5 and 15. So you have basically like 4 things here. 2D NumPy array, random values between 5 and 15 with the shape of 4 by 4. So in this first part of the question, it has, if you divide it, you can divide it into 4 parts. So it will help you to understand it. So if you don't understand how to do any of this part, then answering the question will be a challenge. So I'm just giving you tips on how to approach questions, like especially in data science. If you see a question and you don't try to break it down, it's going to be overwhelming. It's going to look overwhelming to you. So the best thing to do is to take that question, split it into different parts, and try to see if you understand the different parts that you split it into, all right? And then approach it from there, rather than approaching it from a holistic point of view, which most of the time is not the best approach to use. So once you've understood this first part, then you know that after you've done that, you can now use NumPy functions to find the minimum and the maximum values. And now, both column wise and row wise. So you can see the second part of the question can also be split into two parts. So the first part is to find the minimum and maximum, while the second part is to what? The minimum and maximum, you should find it, but according to the column and also according to the row. So this question carry a lot of sub questions, all right? So you can see the simple way to do that is just to also use the rounding function from the random module, and then specify the range, and then also specify the shape. If you're confused on how to specify this, you can always use your shift tab, which I've told us multiple times. You'll see here the parameters. This is the first parameter, low, and this is the second parameter, high. The third parameter here is size. So if you're not asked to use any size, you can as well just not include it. But now I ask us for a particular size, then you have to include the size here, all right? And you can as well indicate the data type. So I'm just, in case you don't understand how to, if for how to use, you can just quickly do that shift tab and just get a quick glance on what to do. So once you've created the array, you can now like get the minimum value column wise, sorry, row wise, which I explained already, and the maximum value row wise, and also get the minimum value column wise and maximum value. So you get all this. So, you can see this is straightforward, all right? Like these are just simple questions. So the question theory, let me just quickly go over this because of time. Given a 1D array below, reshape its array into a 2D array with 3 rows and 4 columns. So you're given this array, I expected to convert it. So you're just trying to test your knowledge on reshaping. So you can basically reshape it by indicating the new shape right here. So can someone quickly tell me the alternate of reshape that's or the function that is similar to reshape that I explained in our NumPy class? We have reshape and that performs almost the same thing, but has a slightly different from it. Exactly. So it is resize, all right. So just to refresh our memory, what resize does is that it can resize or reshape your array and not pay attention to the number of values in your initial array. So you can specify a shape that is more than the original size, and you can specify a shape that is less than the original size. So it is more flexible than the reshape function. All right. So so there is it. Okay, someone is asking for question 2, you think row wise should be 0. Now I explained this to us last week, right? When you want to aggregate an array based on rows and columns, if you want to aggregate row wise, your axis should be 1. So what will happen here is that we have how many columns here? 4 columns, right? I want to aggregate it into what again? So we want to aggregate it into want to aggregate it based on the rows, all right? So what happens here is that each column will be compressed into a row. So this 9, 10, 14, 13 will be compressed, or sorry, it will check through this column and pick the highest value, or sorry, the lowest value. All right, come here, check through this column. Um, sorry, it will check each row, all right, and um pick the lowest value, check each row and pick the lowest value. That's for minimum. And for the maximum, it does the opposite. It checks each row and picks the highest value. It does the same thing for each of the row that we have here. So basically, the one here means that you're aggregating the rows basically, all right? But in a sense, it is each value from the column that you are actually aggregating into a single row, right? So you're aggregating everything um in that particular row into a single value. So this actually is 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 quite confusing. But one thing you just need to have in mind when the performance operation is that normally when you are talking about row and column, anything row in NumPy is equivalent to 0, while anything column is equivalent to 1. But when it comes to aggregation, if you are asked to do a particular aggregation row-wise, just know that the axis that you'll be aggregating from is the column axis. That's basically the rule of thumb for this. So the axis you'll be aggregating from when you're aggregating column-wise will be the row axis. All right, so that is basically how you approach this. I don't want to just go over that, and because I think we already went through this already in the last class. Um, so yeah, so let's just move ahead. So this is the reshaping. So you can see we've reshaped this already to a new shape. All right, we've reshaped it already to a new shape, which is 3 by 4. So we have 3 rows and 4 columns here. So now for question 4, given a 2D array, resize this array shape to 3 by 2. And okay, now I have this question here. So this is just the same thing as the above question, but I just had um to just ensure that you also understand how to use the resize function as well. So we are given a 2D array, which is this. So you can resize the array to shape 3 by 2. How does resizing differ from reshaping? Let's show the result now. So you can see what we have here, right? So you can see the basically we don't have the resulting array still has the same size. All right, so it's just to show you that you can still perform the same reshaping with resizing, but there's actually a difference. All right, so we yeah, so just help you understand the difference between these two functions. So let's just move on. Now question 5, we are asked here to create a 3 by 4 array of random integers. So this is still the same thing, but after you created it, you should transpose the array. So you can come here and create that and just, so all these questions are quite straightforward. So this is for concatenation. So you have your 2 arrays, you can concatenate it along the row axis and along the column axis. So basically, you can do that by just specifying the axis at the end and specifying the 2 data frames or the data frames. Sorry, the arrays you want to concatenate. All right. So that is just it for that. Question 7. Create one D array of text elements. This is just to test your knowledge on the splitting function. So I explained that. So the result should have 3 outputs, all right? As you can see, the first output has four values, second output has four values, and the third output has four values as well. So this initial array that you created here with 12 values was split into three parts having equal number of elements. So the third on the eighth question is give a 3D array below, flatten this array into a 1D array and print the result. So you already know how to flatten, know what flattening is, converting an array of higher dimension into a one-dimensional array. So the last question, okay, the second to last question we have here is basically concatenation too, but using V stack and H stack. I don't need to explain more on that because it's quite straightforward as well. So because of that. So the last question is create the area of this particular shape with all elements equals to one. Add one the array of shape theory with so it's just to assess your knowledge on broadcasting, but you could have actually in this case used np.ones instead of doing it like manually. That is much more efficient than just writing out the element individually. Right. So I just said np.ones and specify the shape 3 by 3 and to automatically produce a 3 by 3 array of one here. So that is it for the assignment. I've not graded anything yet, so right. So even if you have complaints, you'll have to wait for the assignments to be graded, so I can know exactly I can know how to approach it. So just take note of the correction we've done today, and anything that you feel you got or I didn't give you the mark you deserve, then you can come forward on that. So yeah, that is it for the assignment, and well done to Confidence Chinelo. Right. So we're going to go over to today's material. So we'll continue from where we stopped yesterday on pandas, right? Looked at several things yesterday. We introduced pandas. We looked at the data structures that are used in pandas. We looked at series. We looked at data frames. We looked at the different attributes of a series basically, and look at the things that you can do with a series. And basically, we spent majority of the time exploring the series data structure yesterday. So I believe you should have an idea of what the series data structure can be used for. All right. So today we are going to continue from where we stopped yesterday. So yesterday I introduced us to Pandas data frame. All right. Introduce us to Pandas data frame. And someone is saying something. Yeah, Precious. Please, can you just remind me what your question was again? So I would ensure to go over that because I told you I was going to cover it today as well. Okay, so today we'll be looking at pandas. We actually introduced pandas data frame yesterday. Okay, I dropped a poll on the live chat and just 28 persons has interacted with it. I don't know why, but I'm going to pin it now so you can just immediately have access to it. So, all right. So I'll just quickly go over this. So I talked about pandas data frame, how it is a two-dimensional, size mutable, potentially heterogeneous tabular data structure. It is conceptually similar. So I just gave a lot of I made a lot of comparisons with Excel. So when you think of Excel spreadsheets and how data is structured in rows and columns, you should think of data frame in the same light and actually looked at. We actually saw an example yesterday. So yeah, they should not be entirely new to you today. So we went over this yesterday. We looked at the characteristics of data frame, looked at labeled axes, told us that the rows and columns are all labeled, unlike the series in which only the rows, that is the index, is labeled. So it doesn't have it has just one column, all right? So there's no need to label anything there. So we're going to quickly look at we looked at this already, so we see that it has heterogeneous data, unlike the series which has homogeneous data. All right. Looked at who said that it is size mutable too, and it's also efficient because of its architecture. Right? That means it is built on NumPy, which enables it to run very fast. So yeah, we're now going to be demonstrating how to create data frame. So let's just quickly create a new data frame. All right. Okay, so I'll import pandas as PD. Okay, this is me importing the world's library. All right, so now I should just be able to put it up frame. All right, creating a data frame. So I'm just going to you all are going to help me create a data frame now. Um, before creating a data frame, or rather, what particular function am I going to use in creating a data frame? And what data would I impute as an argument into the function to generate the data frame? So just a quick one. You didn't answer my first question. My first question is what function or rather class? Okay. Only one person has answered the whole question. That is patience. Okay, yeah, that is it. So we actually have to create a dictionary. All right, so you just create my dit or my data. So I'll create a random dictionary now. So you all can now see how what we've learned previously is now used for in subsequent classes or subsequent um some things that we'll be doing subsequently. So it's not like you were learning dictionary like a few weeks ago just for learning sake. So this is just to let you know that anything you're learning here is just a part of a whole, all right? So you need to understand all these things so you'll be able to understand the bigger concepts. So now let's quickly, so what am I going to use here? What am I going to use? What am I going to use here? Okay, let's say universities. How come? So, Unilag, Uniben, UNN, um, by Unilearn, and I think I'm gonna say Unizik. So just for sake of time, we'll just stop here. So let's see. So we have oh okay. I want someone to tell me what the problem is with this code already. Like there's an issue with this code I just wrote now. If I run it, it's going to give me an error. So can someone just can someone just what is your university? Someone said my uni is not listed. All right, tell me your uni, so I'll put it here. Exactly. Thank you, Precious and Tijani. Square bracket is missing. Exactly. So it has to be in a list. All right. It has to be in a list. So I'm going to put BSU. All right. So it has to be in a list. So when you're putting multiple things, so I think we're going to have what other variable are we going to have here? Okay, let's say location. Come here and say thinking like is Lagos. Unit Ben is Benin. Benin is Enugu. Where is Ibadan? Unilorin is Kwara. Music is where? Music is Anambra. BSU, I think it should be Benue State University. Let's just include one more. We have CSU. CSU, that should be Taraba. Taraba. Alright. So we have the locations, and then let's see. We can have, let's say, the population of students. Yeah, population. So this is not an accurate figure, so just a random figure. All right, so we can have like let's say 15,000. Let's say 12,000. Let's say 13,000. Let's say 17,000. Let's say 11,000. Let's say 10,000. Let's say 11,500. So we have, now 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Is the remaining one. So I can say 14,5. All right. So we're going to have this okay, numbers on this population size. All right. So I want to add one more variable. So any idea on any variable that can be added here? So I've actually come to love just interacting with you all, right? I don't want it to just be one way something. So whatever it is I'm doing, you should be fully involved. Um courses, how do you think I should include? I should include, like, is it the number of courses or all the courses they're offering? Like, I should start listing all the courses, or what do you mean exactly? All right, someone said year of establishment, CGPA. So yeah, I understand that we are still learning all these things. That is why I ask questions like this. So once you are suggesting any variable, you should be able to associate the variable you are suggesting with these other values that you've put here. Do you understand? So for example, now you are asking, yeah, okay, for example, you want to include sex. So how does sex, you ask yourself, how does sex relate to unilag? Does it mean the average sex of all the students? It doesn't really make sense, all right? So you look for something that can actually be associated using a value with that particular data, all right? So thank God we are building intuition on how to work with data. So all these things should help you. So okay, someone said year of establishment, number of courses offered. All right, so let's use those two. Number of courses. Let me make this. All right. So let's say hmm, just a random number, right? Just a very random number. I can come and say 50, 45, 40, 37, 55, um 36, 44, 42. That's how many? 1, 2, 3, 4, 5, 6, 7, 8. I think that should be enough. 1, 2, 3, 4, 5, 6. Remember, I told you that all of them must match, all right? All of them must match. So I can come and say year of establishment, all right? So I can say, let's say 1952. So all these things are just mock data, so they are not accurate at all. So you can, if you want to do the same thing, you can actually look up the actual listing and use them. Let's say 1956. Let's say 1965. 1952. Let's say 1976. Say 19 20. Oh no, that is too far. It is 88. There's 1, 2, 3, 4, 5, 6. So we have 90, 77, and 90, 55. All right. So these are the this is the data we're going to be working with. All right. So now we'll now just run this, and then we're going to create our data frame by coming and saying df. So df is a popular variable that is used in data science community to refer to your data that you are reading. So you can come and say pf.data frame, all right, and put what my data. If I run this, I should get, it should be assigned to my variable, right? So I can now come here and let's say exploring my data frame. So in Pandas, now I don't know if I've told you already, but Pandas is used for what? Data analysis, right? That's why I compared it to Excel multiple times, because Excel is used for data analysis. So Pandas is used for analysis. So any kind of analysis you think you want to do, just know you can do it in Pandas. All right. So this particular program, which is data science program, will give you both the skills of a data analyst and as well as a data scientist. But just note that you can't compare yourself to a dedicated data analyst because they use several tools for their work. There is a lot of them. So we are just using Python now, and there's a lot more involved in data analysis, right? Data analytics than what we are going to be showing you with Pandas. So, but just know you are going to have an idea on how to do data analysis. We are going to be looking at some general universal concept that is applied in data analysis, regardless of what tool you are using and what's not. So now we've created our data frame. So I'm going to be taking us through the common data frame attributes we have. Remember, I looked at series attributes, looked at some attributes of series. So we are also going to be looking at common data frame attributes. So I listed out some important ones here, although there are lots of them. All right, let me just give you an idea on how much they are. So I can come here and say print df or dir rather, and say df. You'll see that we have a lot of them. Like this is a lot, right? So by now this should be at your fingertip. Like anytime you forget something or anytime you can't remember a particular function. And one thing about this is that it is organized or sorted alphabetically, so it makes it easy for you to even search for a particular function. So if you're looking for a function, you know that function starts with S, or you can't remember the full name, you can easily just come here and go follow the alphabet and go to S, and then you can just skim through it until you see the function you're looking for, and then you're going to call it. And if you still don't remember how to use the function, you can now use Shift and Tab to get the description of that function. Have you seen how easy life is with all these helper functions and all these things that Python has created for us? So because they understand that there are a lot of things to learn and there's a lot of functions and all of that. So Googling sometimes might be hectic. It might be distracting, leaving your Jupyter notebook to another tab. So instead of you to leave to go and Google, you can just do all these things I've showed us, and you'll get what you want. So there are a lot of functions here, but we're going to look at just a few of them. You can explore on your own later on. So we're going to see that now. Okay, I'm going to just explain that. You can see something. You can see that we have year of establishment here. We have universities here. What columns do we have again? No, this thing. Population. We have what population. What do we have again? We have number of courses. Oh, what is n number of, okay, so basically this dir, as I said when I was explaining the concept of attributes and method, it gives you the attributes and the methods specific to a particular object. So the object in this case is this df, and we know we've created a data frame that has these different columns. So these columns are automatically attributed to this particular object. So when you use this dir, it includes them as part of the attributes. So I'm going to show us, although I showed us yesterday, but I'm still going to do that again. So let's just move forward. But this is how you can check out the different functions, right? So I'm going to come here. Okay. So now let's just start with these things, these attributes we have here. First off, we have df shape. What does df shape mean? I showed us this yesterday. This attribute returns a tuple representing the dimensionality of the data frame. This tuple consists of two elements. One, the number of rows, and two, the number of columns. All right. And this is helpful for quickly finding out how large your data is. So most of the time, when you just load your data into Pandas, the first thing you almost want to do, or the second thing is to understand how large your data is. So you can just quickly come here and see df.shape, and then you see, oh, my data is not even large at all. It just has 8 observations and what, 5 columns. All right, based on what we created here. All right, so that is what DF shape does. Hope everyone can still hear me and you're still following. Please, just a quick one to be sure that I'm still here. Chukwuka, you said number of international publications. Maybe when you are doing your own, you can add it. There are a lot of things to add actually. I think this hints at maybe you are into research or something. That is good. So that is also a good attribute for university. Okay, Samuel, you said my voice is breaking. Please, can everyone else confirm if it is true or just him? All right. So let's forge ahead. Let's forge ahead. I hope everyone is loving the class. Okay, so now the first thing, then my voice is in slow motion. How exactly is that possible? HOA. And please, HOA, you've been told several times to change your name, your Telegram name. Honestly, it's not nice that you still have these initials here. Please do well to change your Telegram name as even if possible during the class or after the class, all right? So we don't have issues with anything regarding grade and all of that. So yeah. And regarding the attendance, I'll be sending the attendance in 30 minutes. So by 6:30, the attendance will drop. So the same thing that you did yesterday should be replicated. Okay, so getting okay, so this is a function to get the shape. So we have another function here which is columns. All right, df.columns. So what df.columns does is that retrieving the columns. So what df.column does is that it's it returns the columns we have. If I run this, we're going to return a list carrying all the variables, all the columns. So you can see here we have universities, we have location, we have population, we have number of courses, we have year of establishment. So you can see that things are getting interesting. So that's another function. So let's just move ahead. So we can, so you see what it does. This attribute returns the column label of the data frame. Understanding your column names is crucial for data manipulation and accessing specific data within the data frame. So I'm going to show you something, but let me quickly come here and change university to capital letter. Okay, so the next one we have here is what? df.index. So you've seen this already in the series part. All right, so it's not a new thing to you. So getting the index of our data frame. So I can come here and say df.index. So it will just show you, basically give you a range, right? So you would see that this is the output you get. You get the starting point and then the stopping point. But when you use custom indexes, you are going to get something different. All right, but in this case, we are getting, because we don't include any index here, then we are actually going to get this output. So in this case, now there's something I need to tell us about indexing. Indexing is a way to identify a particular row. So all the values in the index must be unique. There must be no duplicate in your index. So there are some situations where one of the columns, right, are actually unique values. So you can use them as your index. So in this case, university here can serve as the index. So there are two ways to do that. You can come here and initialize the list separately. Let's come here. I can say in the index, right, and come and paste it. So this is a list. So I can now come here and say index is equals to index. So you do understand what I did here? If I run this, what's the error here? Okay, sorry. Should be this and not this. Okay, where is this giving me error? On hashable type list. Okay, just not to waste time. We'll come back to this. But quickly, this we have two methods of doing this, right? But this is the first method which we're going to look at, but I don't want us to waste time. So I'm going to quickly look at the second method. Well, let's continue where we stopped. So when we get there, we're going to explore that. So let's keep on going with the attributes that we have. So the next attribute here is df.datatypes. So if we come here, getting the data types of the data frame. All right. So I can come and say df.dtypes. What this does is that it basically gets all the columns in our data frame, all right, and tells you the corresponding data type. Unlike series has just one column, so it's just outputs just one particular data type. But for for data frame, it returns the data type of each of the columns we have in that particular data frame. So that is what you're going to get. So you can see in this case, you have several data types here. We have universities. The universities of column is an object data type object. The location is an object. So anything string will just be regarded as object. All right. So the population is an integer. Number of courses integer. Year of establishment integer. All right. So that is basically how you that's basically how you get data types. So for the next thing here is df.size. So the size basically give you the total number of elements, getting the total number of elements in our data frame. So if you're already used to NumPy functions, this should not be a problem. You can see the size is what 40. If you count everything here, you count everything in value 1, 2, 3. You saw everything is what 40. The same way we can use this in NumPy, the same way we can use it here. All right. So let's quickly move ahead. So the next thing we have here is ending df.ending. So it tells you, although this is not really a useful function, because you already know that the dimension of the data set is 2-dimensional, right? So I honestly don't know why they included this, but anyways, you can see that it will give you 2. We also have what again? Transpose df transposing. Okay, we're going to look at this later for some reasons. Let's quickly look at the last one. df.values. All right, so if I come here and say df.values, getting the values of our data frame. So I'm going to come here and say df.values. All right, you can see that it just output each observation. This is a 2-dimensional, right? So, but it gave us this in a list, a 2-dimensional list. So you can extract anyone that you want. So you can just, you know how to do that already, because this is a NumPy array. So you notice something, that most of the outputs that we have here, they're actually NumPy array. So you can see here, this is an array. So everything here is so this works seamlessly. It is integrated, well integrated with NumPy. So those are the common functions and attributes that you'd be using mostly just to explore your data frame. All right, just to explore your data frame. So we're going to move on to the next thing here, which is basic data frame operations. So now, okay, I've already created my data frame. How do I work with it? Like what can I do with it? So the first thing, or one of the first things you do when you've gotten your data, you want to see it. Right, all the things we've done here, we've actually not seen our data frame yet. Like, I don't even know what it looks like. All right, the only thing we've seen here is just the dictionary that is here. All right, just the dictionary. So we can't really see this thing in a data frame format. All right, so we have to come here, and we have functions for that. So you can see viewing our data frame. I can come here to view our data frame. What you just need to do is just use a function called df.head. Yeah. Or you can just say df. Like, df will give you your data frame. If you write df here in your data notebook and run it, this is what it's going to give you, similar to what we got yesterday, right? It automatically arrange them in rows and columns. So you can see it has automatically generated rows here from index 0 to 7, and then each observation is in one row. So unilag is in one row, unibn in one row, and everything. So now we're going to try to make this particular there was a question someone asked yesterday, and I think this is going to answer it. The person was asking, what if we have a data that has a lot of rows and we want to give manual indexing? How do we do that? So this is an example of that, right? So in some cases, you might have your data, and one of the column here is suited for, is suited to be used as the index. All right. So the way to do that, you can do it manually, like even before, let's say when you are creating your data set, you can do it manually. Yeah, that's what I was trying to do. So let's try to find out what's wrong with this code. So if I come here, I think I'll just have to delete this variable that is here. Delete index. All right, so I'll come here and say index list. Okay. 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 Sorry. This is a very, very silly mistake. This index should be I don't know. This index should be in the data frame that you are creating, not in the dictionary. I don't know why I kept doing that, but the index should be in the data frame and not your dictionary. I think so. I think it's like someone said that in the group. I don't know. Let me check. Because if someone did, that means tries. Okay, I don't see anything. Okay, so this index should be in the data frame function, not your dictionary. I don't know how I was just mistaking it. These are the common mistakes you can do as a programmer, regardless of how long you've been in it. All right, so don't beat yourself up about it. It happens a lot. So you just make sure that you are able to bounce back as fast as possible. So we've done this now. Let's come here and print. Let me delete this column. Let's come here and reprint this. So if I reprint this, you're going to see what happens here. That the university label here, the university label here. Okay, okay, it's true. Yeah, someone said the Tijan index should be in DF. Yeah. Thank you very much for that. If I had like gone through the chart, then I would have. So this is basically how you can set an index. So in this case, I just manually set the index in this place to the university here. So I can come here and just remove these universities. Let's just remove the universities, all right? Run it again. And if I come here and run it, you see I'm just going to, so you can see that the universities here are the indexing just because they are unique. So you can know that, okay, this first one is what for Unilag, this second one is for Uniben, and so on and so forth. So this is basically how you can just play with the indexing. So if we look at what we looked at the other time, which is what the indexing, right? df dot get index. So let's just quickly look at that. That is df dot index. You're going to see we have a different thing here. It gave us the list, right? The index as a list. All right. So this is how you can try to understand your data. So let us move ahead with the basic data frame operation. So in this place, we have two ways. I've showed you one way that you can do. You can just say df and it will print out your data frame. Right? You will see it. Now, most of the time, your data frame has a lot of columns. Like it can have more than 1,000 columns. So using just df is not practical, right? Although Jupyter Notebook compresses it, you just use an ellipse to kind of just cut it and give you just the top and the bottom, right? But most of the time, what you just want to do is just view a section of the data frame. So the function to use in that case is df.head. So what df.head does is that it gives you the top 5 rows by default. All right. It gives you the top 5 rows by what default. So if I come here and run it, you see that it gave me just 1, 2, 3, 4, 5, the top 5 rows. So I just want to see how the data is structured, what is involved here and all of that. All right. So this is basically what you are going to see when you use df.h. So it can actually take parameters here. If I put, by default, it takes 5, right? If I put 3 here, to give me just 3. If I put 2 here, give me just 2. Even if I put 1, let me change this to code. Even if I put, let's come here, it will still obey me, all right, and give me just 1 row. So you can basically change any number. You can make it 15, but the problem is that our data frame is not 15. It just give you everything, right? So depending on how much you want to see at the time. So, but if you don't put anything by default, it will just return the top 5 rows for you. That's it for head. We also have df dot tail. So you obviously know what tail will do is the reverse of head. It give you the last 5 rows. So by default, it give you 5. So you can say from the bottom, give you TSU, BSU, Unizik, Unilorin, and UI. So you can still manipulate it or change the values, like if you want, and all of that. So the same concept, the same thing with why are we just bothered about attendance? I told us that the attendance would be posted on the group chat by 6:30. Is it that you just, I don't know. Anyways, so this is how you can just check out your data frame to see what is in it. All right. So okay, your battery. All right. I don't know about I'm going to post it by 8:30. Just try to hang on to then. Believe you knew the time for each class and should have at least prepared before now. So let's move ahead. Now I'm going to introduce another one, but which we didn't include here. It is called df dot sampling from our data frame. All right. So if we don't want to, if we just want to view random samples from our data frame, we can use what we call df.sample. All right. So what df.sample does is that it randomly selects one row. So if I run this again, it give us a different value. If I run this again, give us a different value. If I run this again, give us a different value. So it is randomly sampling from our data set. So most of the time you want to view a random sample, right? So to manipulate the output, you can change or put by random, it gives us just one sample. But you can actually change the number here by including if it's 3, give it 3 random. So if I run it again, you can see how it is randomly sampling from our data frame. All right, so it is random. If I put 5 here, the same thing, all right, is randomly sampling from our data frame, all right. So that is basically how you can just explore your data set. So these are ways to view your data set I've showed us already, all right. Now, I want you to take note of this. Remember, if you notice, while we've been using Jupyter Notebook, any code that is above the last code, you are not going to see any output unless you use print. All right. Let me just say something here. Pass. So basically, there's nothing showing here because pass. This pass is just a code in Python, a Python keyword that doesn't do anything, but Python recognizes it, so it doesn't give an error. So now we see that all these things that we've done here is not displaying. So you might be thinking, okay, for me to just enable you to display, let me just come here and say print so that my data frame would be like, you understand? So this is what you'll be seeing. Now, this is a warning. If I give you an assignment and you use print df for me, you're going to miss that particular question. So that is why I'm taking my time to say it now. What you should use for data, you can use print for any other thing. When it comes to data frame, showing or displaying your data frame, what you should use instead of print is what? Display. Display. Why? You can see what print gave us. You might not know the importance until you have a long list of columns. Everything will be scattered and all of that. But display will still retain the format of a data frame for you, regardless of where it is in your cell. Even if it is the first thing, as long as you use display, it's going to still display it for you, retaining the format, the original format. So this is something you should note and keep at the back of your mind. So display is a function that should be used to display your data frame. Don't use print for me. I'm begging you. Unless maybe your data frame is the last thing here. Maybe df.head is the last thing here. That's fine. You can as well. You see to print 2 of them, right? So that I just wanted to note that so you take notes. Okay. So let's move ahead. We've looked at all this. Let's forge ahead because we still have a lot to do. So now back to yesterday. I think this was what I was looking at yesterday before we call it a day. So I'm going to be while we're typing our names on the attendance group chats. Okay. Anyways, so we're going to be looking at how we can select columns and rows. So this is similar to indexing and slicing in NumPy that we've been doing, and also series, selecting columns and rows. Now I'm going to start with columns. Remember in the attributes that we did before, we saw that all the columns in the data frame, they are part of the attributes of that object, all right? So you can use it the same way you would get the attribute, any other attribute, the same way you can access that columns. But there are two ways to access your columns. So first of all, okay, now to get all the columns in my data frame, now what will I do? Because I actually need, maybe I've forgotten the columns, so I want to see all of them. So to get all the columns in my data frame, what will I do? I said this like a few minutes ago, so we should be able to answer that. I'm still waiting for responses. All right, we are all correct. We are all correct. It's df.columns, but it does not have a bracket because it is not a function. All right, it's an attribute. So you can now see all the columns here. So I can now start using them. So I'll come here and say I want to select the column, the location column. How do I do that? I can come and say df.location. All right, you can see it's a df.what location. So remember the same way we use df.columns, the same way we can access the variables of a particular data set. All right. So you can see that these columns are attributes of that data frame object. So if you run this, you see it's going to give us a series, right? It's going to give us to give us the index, obviously, which is a characteristic of a series, and the corresponding column we are trying to get. So this is the location of each of the this is location of the universities, right? The corresponding university. So if I do the same thing for, let's say, df.population, I'm going to get this, right? Do the same thing for df.number of courses. So you get the gist, right? So this is basically how we can access columns in our data frame. So this is the first method. So let me just, I told you that there are two ways. First method of accessing our columns. Now the second method of accessing our columns. So the second method is just by using brackets, like square bracket, the same way we index something. So we can come and just say this location, all right, to give us the same thing. I can come and say df.population. You get this. I can come and say df.what? What other columns we have here? Number of courses. Make sure that is in when you are using the first method, you don't need to call it as a string because it's an attribute, right? But when you're using the second method, you need to call it as a string, right? Because you're not calling it as an attribute in this case, right? So this is so what is, okay, sorry. Someone said my screen is blank. Is it true for everyone? All right, so I'll be showing the attendance now. So you can go ahead and fill the attendance. So you should see the attendance now on the attendance group. All right, someone said, but said you'll be pasting in one after 1 hour of lecture. Yeah, adjustment can be made in certain situations. My assistant is not available here, so things are not going as it has been going before. So definitely we can be flexible about that. So that shouldn't be a problem for anyone, I believe. Okay, so please just fill out your name in the attendance form. So this is how you can actually access your columns from your data set. So these are the two methods of accessing your columns. So please just take note of that. It's something you're going to be doing. And when you access your columns, you are going to be getting the output as a what series. You're going to be getting the output as what a series. Let's move on. We have a lot actually to do. So we've talked about accessing columns. Now, how can we access our rows? So the same thing. I believe this was the question Precious asked yesterday. Accessing our rows. All right. So I can come here to access your rows. You can either use iLock or what lock. What does iLock means again? Can someone remind us? What does iLock means again? Said in yesterday's class. Exactly. Exactly. So iLock is index location. It is used to access the row index basically. So if I use iLock and I put a number there and I say 0, I'm going to be getting the first row as a series. So what you're saying here is the columns would be, at this point, the columns will be the what? The index. Why the value for that particular row will be the column for the series basically. So this is what you're going to get. So in this case, you can see the columns here with their corresponding values for the first row. So if I come here and make it 2, let's say I want to access from 0 to 4, you can now see that it has now converted it to what? A data frame. Because I'm slicing, this is now slicing, all right? I'm slicing a particular section. Remember I told us that we can do this. We can use df.sample to get, let's say, 4 random samples. So we can actually be more specific with the iLock. So with iLock, we can actually be more, let's say we have like 10,000 rows and we just want to get maybe the 900 to 1,000 or 900 and something rows. So you can actually include it here. You can say 900, all right, to maybe 921 or something. So it will give us it will not give us anything, but if you have that, it's going to give you the corresponding rules that you are asking for. All right. So that is for iLock. You can basically say, let's say 4 to 8 to just give you this output. So that is how you can access your rows. So you can, if you want to access just one row, you just put one value and to give you a series. If you want to access multiple rows, You can do this, right? You can do this 7. All right. So yeah, and there's something else. If you want to access your rows, a specific row or specific rows with a specific column or specific columns, you can actually modify this code. So after you've done this now, right, you will now come here and put comma. If you don't put any comma, by default, you're going to be getting all the columns. That is by default. But if you, after your row index, you now come and put comma, and you now specify your columns, all right? So let's say I come here and say location. No, sorry, because this is index, so I have to make it a number, all right? So I'll come and say 0. 0 is what? The first column. So if I go to our column, you can see the location here is the 0 index, population is the 1, 2, 3, and all of that. So I can just basically do the same thing. I can come here and say I want to get from 0 to 4. That means I want to get from location, population, number of course. So these 3 rows, these 3 columns, and I don't want to get this one. You can specify it here, and if you run it, it will give you this. All right. Sorry, 3. All right. So 0, 1, 2, 3. So this is basically what you're going to get. So you can modify your code, but just make sure that after you've written this first part before the comma is for rows, second part after the comma is for columns. So this is something that will come in handy as you're progressing. So the second way you can do it is by using the in location without the index lock. So lock will require you to specify the name of your row. You understand? So in this case, I already have my rows have names, labels, right? So in this case, I have, like, let's say unilag. If I just run it, it's going to give me the values for unilag. If I come and say unilag to let's say okay, unilag to UI. You see, it's going to give me, right? So you can be more specific with the labels or the index labels, right? So these are 2 ways you can access. You can actually come here, still even put comma and put, let's say, location. You give just location column, and you want to like include more, you can say location to number of courses. So there's a lot of there's flexibility while using pandas. You understand? Like with just all we've done now, you can start to imagine how you can do a lot of things, especially when you have a data set, right? So there are a lot of manipulation that you can perform on your data. So let's just move forward. So that is it for accessing rows and columns. Precious, I hope you understand now, because I believe this was a question we were trying to ask yesterday. So let's just move on to the next thing. Now we're going to look at Boolean indexing. So this is another way to select data, selection of data. All right, we're going to look at Boolean indexing. So let's quickly move on to that. So I really hope we cover all these things. Selecting data via Boolean indexing. So you know what Boolean is, right? Boolean is a data type that can take either true or false, yes. So there are some cases where you want to select only those universities that have population greater than 12,000. Maybe that is what your analysis requires, or you just want to see them, right? You can use Boolean indexing for it, or you want to select only those universities that the courses they offer is greater than what? 50. You understand? So this is Boolean indexing. It's usually applied to numerical data. Most of it, yeah, it's because it performs comparison, right? You can actually compare string in the same sense, but you can compare um, you can make comparison with numerical values. So let's just quickly look at how we can do that. So in this case, I want to select only those universities that now I can perform on one particular column, and I can also perform two at a time too. All right, so this is the same comparison operation that we did earlier on. So you can see everything is coming into play. So I will come here and say df. Now the particular column that has the population is the population column. So I'm going to come here and say population. All right, population. Now, after I've done it, I'll now say greater than what? 12,000. When you do this, you're going to get a Boolean mask. We call it a Boolean mask. So if you run this, you're going to get this. This is a Boolean mask. Is true. It's going to tell you whether it's going to give you the true value for each of the observation. Okay, in this case, unilag is true. That means it has a population greater than 12,000. Uniben is false. It does not have. UNN is true. UI is true. Unilearn is true. Like that, like that, like that, like that. You understand? So you're going to make that comparison and give you the result of the comparison. But this doesn't make sense, right? You actually want to see the new data frame. So what you do after you've actually made this comparison is to now make this particular comparison you've done now. You now like put it as an index, as if you want to index something in your data frame. So the way to do that is what we'll be doing all this while. You come and say df and then put it in a bracket. So you put everything, all this comparison in a bracket. So it will now be inside a bracket. So if you're having something like this, df, and you have a bracket, and you now inside this bracket, you now have the comparison that we have here. So if you run this, you're going to have this output, and the output is just going to give you only those universities that their population is what? Greater than 12,000. So if you look at the population here, you will not see anyone that is less than 12,000. Are we following? So you can see how useful Boolean indexing is in selecting specific data, right? So we can do that the same thing. We can come here and say df. So you don't need to, you can come and say like for the number of courses, come here and say greater than what? 50, right? If I run this, you see there is only one university that offer greater than 50 courses, which is Unilearn. You understand? So there you can actually generate insight directly with this Boolean indexing already. So let's assume I want to make it 45, right? You see that just to Unilag and Unilearn, you understand? Let's say I want to make it less than 40. These are the lowest here. Unizik and UI, they offer the lowest number of courses, all right? So just put that back in mind. This is a mock-up data, not original data. So these are the ways you can actually select data or extract data from a data set using Boolean indexing by making comparison, right? Comparing a particular column with a value, right? So we can actually even use equal to. So all those things that we did in comparison operation, we can also do it here as well. So if you want to be specific, you can say the one that is equal to 40. The one that is equal to 40 is UNN, right? Or the one that is equal to 100, nothing. So you can explore and just like see how you just play around with it. It's actually a way to generate insight from your data. All right. So let's just move ahead. So now this is Boolean indexing. You can actually do it for one column, but you can also do it for two columns at a time. So remember our logical operation. Now you see how everything is coming into play. Do you understand? we looked at comparison operation. Like a few weeks back, some of you were wondering how are we going to implement this and all of that. Looked at logical operations too. You can see how everything is building up to something big. That's why it's essential that at each class, in each class, try as much as you can to understand what is being taught. Because if you don't, moving forward, you're going to have problem grasping the more advanced concepts, right? That's how you learn. You break things into pieces and you start learning the bits of it, right? So that is the essence of programs like this. We understand the things you need to learn to become a data scientist. So we take you step by step, step by step. So your own is just to follow us. I know you might have questions sometimes, which is very fine. I'm not against questions, but just follow what we are learning, right? Follow what we are teaching so that you won't have much problem with the more advanced concepts. So, but this is basically how you, yeah. So let's go back to this Boolean indexing. So we can do for multiple columns, not just one column. Let's say I want to get the universities that have population greater than 12,000 and number of courses greater than 40. So those are two different comparisons now, you understand? So I can come here and say DF and say population greater than what? 12,000. So what is going to follow this particular code here based on what we've looked at on logical operations? Yeah, yeah, exactly. So and what DF number of courses greater than 45. So these are two comparisons, understand? Let's see. So this is basically what you're going to get. You're going to get just the ones that meet these two criteria. So in this case, we have only two universities that meet this criteria. So this is a very good technique for sorting and filtering our data. Understand? So let's assume you are marking some you are trying to like analyze your student grades and all of that. So you just want to quickly get those grades. The same thing you can do in Excel, right? You can basically use this filter and sort. So you can use this to filter your data to what you want to have. So this is just very nice thing. So if I come here and say DF, so I have to put a bracket here. Um, Sometimes Python just okay. Let's see. I believe the issue is from the issue should be from either of these brackets here. So let's quickly. So these are the things that you would be you might encounter. Where so the error is just a very silly syntax mistake. Understand? So let's just quickly look at what exactly is happening. Okay, I think this one should be a two in a normal bracket like this. Let me check. Okay, this shouldn't be here. For time, so see how I don't know what exactly is happening, but the network just keeps coming and going. All right. So we're almost done actually. We're almost done. So I think it's the same thing for everybody because I can see that most people have dropped out. Hopefully because of the network and not that they're left or something. All right, let me just share my screen and conclude. Um, we'll continue from where we stopped today next week. So please, can you confirm if you can still hear me? Please confirm if you can still hear me. Oh, okay. All right. So we have here. I was trying to show us how we can add and remove columns. All right. So in this case, we have several columns here. The Let's go back to the notebook here. So we can add columns by specifying. Okay, let me. So we have this particular data frame, right? How do we add columns? I can come here and say I want to add something else. I want to add. I think someone said something that I didn't take. Um, Okay, can someone just quickly suggest another variable I can add to this particular data? I just quickly so we can move forward. I'll be wrapping up now. Wrapping up now. Okay, let's go with number of professors. So now to add a new column, let's say we have a new column now, number of professors we want to add. We can come here and see df, and then would the same syntax we use in indexing a column is the same syntax we use, but in this case, it will be serving as a variable. So I will come here and say df number of professors. Yeah, you can see that I'm using this assignment operator here, which means that anything that is here would be assigned to it. So this will be automatically added to my data frame. So you have to make sure that you add the appropriate number of this thing here. So I can come and just say 23, 12, 22, 16, 17, 24, 32, 1, 2, 3, 4, 5, 6, 31, 30. All right. So if I run this, what is the error now? Okay, so the length doesn't match, so I have to remove one. So if I add this and I come here and print my data frame dot add, or rather, let me just go back to this one here. You see that a new column has been added here. Can you see it? Number of professors. So that's very straightforward, right? Like that is how you can add more columns to your data frame. That is why in the characteristics of your data frame, it talked about it being resizable. You can change the size based on your need, all right? So now let's look at how we can drop columns, all right? Let's look at how we can drop columns. So you see that we can add columns. There are several things you can do. All right, let me quickly show you another example. Let's say I want to add another columns. All right, and I want to create a new column based on these courses here, right? And I want to give that column name to be, or let me make it this. Let me make it this population. I want to create a new column which is going to be size, university size. So based on a particular condition, I'm going to indicate whether that university is a big university or not. All right. So I'll come here and say df dot university size. All right. So I'm going to come here and use my comparison operator. So I'll use an existing column I have here, which is population. All right. And then say greater than, no, I'll say large. I'll say large. All right, so this will be the variable name. So if it is true, that means the university is large. If it's not true, that means it's not large. So I come here and say 12,000. All right, and I run this, and I come here and we run this. You see that we have a new column added here. All right, you can see that this large mean that the university, if it's true, that means that university is large. So in this case, you can see true UNILAG is large, false independent is not large, true UNN is large. So you can see how we can add new columns either based on the existing columns or by creating new columns on our own. So this is how you can actually manipulate your data frame and add new columns. So let's quickly look at how we can drop columns, and we'll call it a day. So dropping columns. So to drop columns, you use the same function I told us yesterday, which is drop. This one is not drop NA. Or drop NA is what for what? Can someone remind me what drop NA would do? Please, we are running out of time, so I just need a quick answer. Can someone remind us what drop NA does? Yeah, thank you very much, Akinlabi. It drops a missing number. So that's not what we are using. We are using drop itself. So drop basically would look at the first variable we have here. So the first variable we have here is large, first argument rather. And we don't just call large, we have to specify the axis, right? Are we dropping, because you can either drop a row or drop a column, all right? You can drop a row or what? Drop a column. So we'll come here and say large and then axis equal to 1. If axis equals to 1, then it's going to drop, it's going to look at the columns and look for large and drop it. If axis is equals to 0, it's going to look at the row and look for large. If large is not there, to give you an error. But if you want to drop any particular university, you can just type out the name and maybe you want to drop in a large. You can say in lag and specify the axis is equal to 0 and it will drop it for you. Do you understand? So let's even try that. So you can see I've dropped it, and you cannot see unilag here again, all right? Because I specified axis is equal to 0. But if I come here and say 1, it's going to give me an error, all right? Telling me that unilag is not found in axis, which is the columns, right? So, but if I come and say large, you see that it has dropped large here for me, right? So because I specified the axis, which is 1, and it looked at the columns, that is axis 1, and dropped that large. But there's something you need to note that when you run this particular code, it does not make a permanent change to your data frame. So because if I come here and still, let's come here and still reference our data frame dot head, you see that I still have large here. So what did it do basically? So most of these functions that alters the content of a data frame, they are not usually permanent. So you have to indicate, you have to specify something to ensure that the manipulation or what you did is permanent. So what you have to do, there are two ways. You can either come here and say in place equal to true. So this is a new argument. So in place equal to true tells Python that, okay, this thing you are doing to this particular data frame, make it permanent, let it affect the original data frame. So if I come here and run it, all right, and I come here and run this, you see that it has permanently deleted that row for me. So you have to be careful when deleting something, so you're not just gonna make mistake and delete what you're not supposed to do. That is why it allows you to specify this parameter before doing what you are doing. All right, so you're not do mistakes. So this is the first way to do it. You can also do it this way by reassigning this particular output to a new variable, and you can assign it to the same data frame name here. So if I come here and say drop number of professors, and I come here and run it, many professors, the number of professors. What am I missing? Let's see, let's run this thing again to be sure that this is it now. Let me copy it directly here. All right, so come here and say, all right, so I'll come here and run it. You can see that it has modified the original data frame. So there are two ways you can do that. Either by using in place which I'm going to just quickly write here, drop um all right, and say in place equal to what? True. So these are the two methods. First method, second. So if you don't do it this way, it's not going to affect your original data frame, all right? So yeah, that is what we're going to be stopping for today. All right, this is what we're going to be stopping for today. So I'm going to be taking questions, just 3 persons, please. 3 persons. So we'll move on. If you have any other question, you can ask in the group chat. Yeah, Peter, Patience, and Michael. Please, any other person, please just you can ask your question. I'm so sorry, but I think I've gone beyond my limit at this point. Okay, Michael, Patience, and Peter. Those are the people I called. Okay. All right. Peter, you raise your hand. Please, you're on mute now. Go ahead and ask your question.
Good evening, sir. Mine is not really a question. Today's class is very, very productive. I really understood most of what you taught, if not all. Mine is a complaint, sir. I just noticed yesterday that my assignment was missing. Even after I uploaded things on Tuesday, so I saw it yesterday that it was missing. So I'm wondering how, sir.
Sorry, can you come again?
I said, sir, mine is a complaint. I
This
submitted my
is
assignment.
for questions. Um, Peter, this is for questions, and I know so many persons have questions to ask here. If you have a complaint, you can always lead them in. You can always refer them to the class rep, and he's going to reach out to me.
I did, but nobody responded, sir.
Okay, what is it, please?
Is the assignment, sir. I noticed yesterday my assignment was missing. I complained in the group, but nobody responded.
I've not graded any assignment yet, so I can't respond to any
It's showing
assignment
that mine is
problem at
missing.
this
It's
point.
showing that it's missing, sir.
If it's missing, then I don't know. It probably maybe something happened on your own end. I've not I I don't know until I go through the assignment, then I can give you a tangible answer.
Thank you, sir.
All right. Um, Patience, please ask your question.
Good evening, sir.
Yeah, good evening.
Good evening, sir.
Yeah, good
Thank you
evening.
for today's class. My question goes like this. If from the data frame you have here, you want to add like the number of professors in between the population and number of courses, how do you specify it? The exact position you want it to be is between the population and number of courses. So how do you specify it?
Yeah, there's a function for that. It's called insert.
Okay, okay,
So you can try it out yourself, but we will not be able to do that again today, maybe in the next class. But you use df.insert and
okay,
you specify the index that you want it to be and also specify the data to as argument. So it would place it where you want it to be. But if you just do the normal way, it's just append it to the end. All right. So that is basically how you use that's basically how you use that. So it takes three arguments. It takes the location, it takes the column name, and it takes the value. All right. So
okay,
as I said, there are a lot of things to explore. So when we start working with data sets, we'll see all these things, like most of them in action. But you can check it out
okay,
yourself
sir.
as well. You don't need to wait till then.
All right, thank you, sir.
All right. All right. I think Michael is the last person. Michael, please ask your question. You are allowed to speak. Michael. You're raising your hand. Okay. So Samuel, please just go
Good
ahead
evening.
since Michael is not responsive. Samuel, go ahead and ask your question, please. If I Samuel, unmute yourself, please, and ask your question. All right, so I think we're going to call it a day now. I don't know what is wrong with their internet connection. Maybe MTN doing what it does. But we've come to the end of today's class, and I believe we learned
Hello,
a
good
lot.
evening, sir. Good evening, sir.
Yeah, good
Hello,
evening.
Mr. Emma. This is Fine Samuel. So I'm sorry. My question uh, is not based on this class this evening. Since we started, my phone, I had problem with my phone, and this is my first time joining the class here. I don't know. I've missed a lot and so many things. Even the foundational courses I've not done. I just repaired my phone last week, so I saw all the messages, both email and whatever. I don't know. I hope I'm not. Maybe how do I put it now? I hope I'm still with you guys, or is there any other thing I need to do in order to be in line?
To be honest with you, we've gone far. We've gone really far. This is the 10th class since we started. So, and the fifth week. So, I can't tell you that you are still in line because you have a lot of backlog. But if you can put enough time, you bring out enough time to cover up and meet up, that's fine. It all depends on you. But I'm just letting you know that we've actually gone far. Actually gone very, very far. So, and there's nothing I can do on my own end. The materials are there available in case you want to like go over them and catch up with what we are doing. All right. So, and also the
Okay.
assignments that we have been given to, uh, we've graded a lot of assignments as well. So I don't know what to say aside that.
All right.
All right.
There's no cause for alarm. Okay.
Yeah,
Let me see
but
how it
another
goes.
another option is you can either wait for the third cohort because there's still going to be another cohort after this and start along with us. Because trust me, um, it's going to be very difficult catching up at this point. I'm not saying it's impossible, but it's going to be very difficult because as you are trying to catch up with the previous ones, we are actually releasing more materials and new classes are coming up and all of that. So you're just going to be scattered and disorganized and all of that. So best thing is that just if you can catch up, that's absolutely fine. But if you
Yes, I
can't,
can. Yes. In terms of reading the materials and the following, I can. I will be able to do that. That is my own. But what my fear is that maybe if you not do the foundational code, that means your name will not be included whatsoever. That is what I'm talking about.
no, the only problem you would have is your grade because you've automatically gotten missed a lot of assignments, so your grade is going to be very poor when it comes to that. But you can if you still want to go ahead, no problem. You still have your project to do. You still have attendance and all of that. So you can still follow up if you want. So that's actually fine if you can.
Okay. Okay. All right. I will. I
Uh,
will try my best. Okay, sir. Thank you very much.
all right. So think that okay, Michael, I unmuted you. Like this is the second time I'm unmuting you now, and you seem not to be saying anything.
Hello? No, I'm here. I'm here. Good evening, sir.
Yeah, good evening.
Hello.
Please go ahead with
Good
your
evening,
question,
sir.
sir.
Hello. All right, all right. Again, I will also say my question has nothing to do with this last class. Sorry, I'll be taking us backwards, but I just want to understand a particular function so that I don't make such errors again. It has to do with the assignment you gave us, question 10. I can see you said create a 2D array of shape 3, 3 with all elements equal to 1. And from all you've been telling us, you say when you say all elements equal to 1, it means sum. So I find that description to be likened to a sum total. And when you run a sum, it gives all elements being equal with that particular one you give as 9. It doesn't give as 1. If you create a 2D array with np dot ones, and then if you check, all the elements will not be equal to 1. It will be equal to 9. So I needed to understand that part because you said that you expected the 2D array to be created with ones, np dot ones. So I needed to get a clarification on that. Sorry, sir.
All right. Yes. The thing is that you're actually overthinking the question. The question is
Okay.
just asking you to create a 2D array with all elements equal to 1. That means each element in that 3 by 3 array are equal to 1. Like the first element is equal to 1, second element is equal to 1, and all of that. If I needed you to create an array that all elements, I would have said create an array in which the sum of all elements is equal to 1. That's a different thing entirely. All right. But in this case,
Oh,
I'm just
okay.
asking you to create an array where all the elements are equal to 1. Is equal to 1 basically. So that is just it. So just
Okay. Okay.
don't
Okay.
take the question
I think I
as it is.
yes, I think I overthought it. Okay.
All
All
right.
right. Thank you very much.
All right. So thank you everybody. I'll be calling it a day now. And thank you for your time. And let me stop sharing my screen. All right, so we've actually reduced to like half from it to something to 46. I just hope it is network and not that people send attendance and run away. Anyways, thank you for your time. If you still have any question, please drop it in the Q&A. I'm not promising. I'm not promising to go over it today. I will do that as soon as I regain my strength. So everything will be attended to assuredly. And yeah, so that is it for today. Thank you very much for your attention, your time. Your dedication so far is quite laudable, and I'm also happy and proud of how far you've come. So sometimes you should just take a step back and look at your progress and just clap for yourself. You've actually tried, right? You've actually tried. So, but there's still a finish line to cross. So don't just don't give up now, right? Don't give up because I can see the numbers have reduced, right? We usually have 120 something persons in the class, but now you're having just 80, right? So please, I'm encouraging you, please don't give up. So assuredly, it's going to be something you won't regret. Okay, so that's it for the day. Um, you know the need for rights. Please drop what you've learned in today's class on the group chats and just interact with yourselves and see what others have learned too, and you can pick from theirs. So this is the end of the class. Have a good night rest and enjoy the rest of your week. Thank you.